Hello, fifth graders. Ms. Jagodnik here, continuing our section of math review that deals with mixed numbers. Today, we're going to focus on adding mixed numbers. This goes with lesson 7-8 in your book, which is pages 413 to 418 in volume 1, if you want to review those pages and see how we did this work when we worked on it in class. But those pages are probably already completed from class. A copy of them is online if you want to go over it and try some of them again. But these problems I have up here aren't in your book anywhere. I just want to review the topic right now and make sure that we remember the steps to adding mixed numbers and can do a variety of problems that we might encounter. So the first step in adding mixed numbers, which, of course, is a number that has a whole number and a fraction part, is to make sure that the fractions have common denominators. As we've been talking about the last few days in our review, you cannot add and subtract fractions if the denominators aren't the same. So first I want to check for that. Once I have common denominators, or change them into something with a common denominator, then I can add. And I want to add the fractions together, and I want to add the mixed numbers, the whole number part together, and then I can come up with my total sum. So let's just see how this works. Problem number 1 here, I have 2 and 5/6 plus 1 and 5/6. So again, step 1 is to check for my fraction parts. I have 5/6 plus 5/6. Is the denominator the same? Yes. So that makes it easy. I eliminate that step and I can just add them together. So my fraction part, sometimes I like to draw a line here to separate and keep me a little more organized. My fraction part is the same as 10/6, because we know when we add fractions, we just add the numerators and keep the denominator the same. 2 plus 1 is 3. There's my whole number part. Okay. But now I cannot leave it as 3 and 10/6. That is not simplest form because this here is an improper fraction. I need to change that over to be proper. So if I am doing 10 divided by 6, if I'm talking about 6 size pieces, I know I can get 1 whole out of this. 1 whole would be 6/6, and I would have 4/6 left over. So once I change it into a mixed number, now my job is to put the whole number total together with the fraction total and get my final answer. So I put together the 3 and the 1. That means my answer is 4 and 4/6. Now, remember about simplest form, I can see when I look at 4/6 that I can reduce that down to something simpler. I can see that right away because the first thing I always check for is, are both the numerator and denominator even? Then I know I can divide by 2. So I'm going to divide that by 2 over 2, and my final answer will come out to be 4 and 2/3. That is in simplest form. All right, now if we look at number 2, we see an example of a more complicated type of adding mixed numbers because I check right away here and I see that my denominators are not the same. That means before I can add anything, I need to get common denominators. So when I look at 2 and 4 that I'm working with, the first thing I always check is the higher number I'm working with a multiple of the lower one? Because I know that's a shortcut for me. Then I only have to change one of them. And in this case, that works out. 4 is a multiple of 2. So I don't need to change the 3/4. I can keep that the way it is. I just need to change the 2, the 1/2, into 4ths. And I know I can do that because 2 times 2 is 4. So if I multiply by 2 over 2, okay, I know that 1/2 is equivalent to 2/4. Okay. So now I can add, on the fraction side, 2/4 plus 3/4. That gives me 5/4, and 3 plus 1 gives me 4. Okay. Now 5/4 I notice is improper. The numerator is bigger than the denominator, so I can change it into a mixed number. 4/4 is 1 whole, so I can take that out, and I have 1/4 left over. When I put my entire sum together, it will be 5 and 1/4. I don't need to worry about changing 1/4 into simplest form. I don't need to reduce that down because when it's a unit fraction and 1 is on the top, I know I can't go down any further. Number 3, following the same steps, I see the 10 and the 4 need to be put into common denominators. So I'm working with 10, I'm working with 4. Do the same thing I do over here, and I'm going to check, is the higher number 10 a multiple of 4? And it's not. So now I know I can't just use 10. I'm going to have to change both my denominators into something else. So I need to find something that's a common multiple. Okay, so let me write out my multiples list here. 10, 20, 30, 40, blah, blah, blah. Multiples of 4 are 4, 8, 12, 16, 20. Oh, wait, 20 is on both lists. So now I know that I can change tenths into 20ths, and I can change fourths into 20ths. I'm so glad I used my multiple list strategy, because the other thing I could have done is just said, well, let me do 10 times 4. They'll both go into 40. But because I use my multiple list, I actually discovered that while I could have used 40, there's an easier one, a lower one I can use, which is 20. So to get to 20, I would have to multiply the tenths times 2 over 2, which would give me 6 20ths. And I would have to multiply the fourths times 5 over 5, which would give me 5 20ths. So now I can add 6 20ths plus 5 20ths. This side would be 11 20ths. And over here, I can add 2 plus 5 and get 7. Oh, this is different than the other ones. This is not an improper fraction. It's a fraction less than 1. And 11 is a prime number. Nothing I can divide this by that will get me any simpler. So all I have to do is put these two pieces together. My final answer here is 7 and 11 20ths, even though that's not a fraction we see a whole lot of. That is in simplest form. Number 4 is a little different because I got a blank space here. So I just wanted to show that to you in case you run across one like this. This is really 0. 3 is a whole number, which means it has no fractional part. So all I have to do here, nice and simple, this is like adding nothing to 4/5. So on the fraction side, I would just keep 4/5 the same. 2 plus 3 is 5. So altogether, my answer is 5 and 4/5. That's already in simplest form. I'm all set. Okay, I want to go over here and follow my same steps. I've got 10, I've got 5. They are not alike. I need a common denominator. Oh, look, I looked out. 10 is a multiple of 5. So I can keep the 4 tenths the same. To get to tenths, I can multiply this times 2 over 2, which means 3/5 would be the same as 6 tenths. So now I add these two together and I come up with 10 tenths. And I add 8 and 2 together and I come up with 10. Well, that is the weirdest looking answer we may have gotten so far, 10 and 10 tenths. But what does it mean? This has to be changed. This is not a fraction less than 1. It's also not really an improper fraction. What it is 1 whole. If I have 10 out of 10, we should know by now, numerator and denominator the same means it's equivalent to 1. So I'm going to change this into 1, and that means I have 10 wholes over here plus 1 more whole over here. My final answer is just 11. Sometimes it works out that way, that your final answer when you're adding mixed numbers is a whole number, not a mixed number. It just depends on how those fractions come together. Last one we're going to do together here. Oh, now I have a space over here, so I wanted to show you that kind of problem as well. Doesn't affect what I'm doing over here. I see I have a 3 and 9 as my denominators. So yes, I need to find a common denominator. And 9 is a multiple of 3. So to change into ninths, I'm going to multiply times 3 over 3. And that gives me 3 ninths. I don't have to change this at all. It's already ninths. So 3 ninths plus 2 ninths. I have 5 ninths altogether over here. That is in simplest form, so nothing to worry about. And then I just bring down the 3. If you want to fill in a 0 and make yourself feel better, you can, because this is just a fraction. So 3 plus nothing gives me 3 wholes. And together, everything's already nicely in simplest form. It's just 3 and 5 ninths. Okay, so quick and easy review. That's your steps for adding mixed numbers. First, you check for a common denominator. If it has a common denominator, go ahead and add. If it does not, You need to use your equivalent fraction strategy and find a common denominator and then change them over into equivalent fractions that have the same denominator. There's a few ways you can think about that. You can look at the bigger denominator first and see if it's a multiple of the smaller one. Then you can take a shortcut and only change the smaller one over. You can check multiples lists to see if you can find the lowest common denominator, or you can simply multiply the two denominators, but know that that might not be the lowest, most efficient one to use, so you might have to reduce it down more to get the simplest form afterwards. Once you've got your common denominators worked out, you add the fractions together, you add the whole numbers together. If the fraction turns out to be an improper fraction, or a fraction that's equivalent to 1 or greater than 1, then you need to change that over into simplest form, add it with the whole number part, and get your total answer. Finally, check your fraction, make sure it's in simplest form, and you can't divide it down further. Those are your basic steps. You can go on and try your practice buddy to make sure that you can do them independently. And as I said, there's a visual learning video in your assignments, as well as the online pages for 13 to 418, which go with this lesson that you already did in volume 1. So have a good time reviewing that, and I will see you again in a couple of days. Just remember, tomorrow, because it's Brooklyn Queens Day and the teachers are in virtual meetings all day, there will be no live classes, but check the slides in your Google Classrooms and make sure you sign the attendance slide and hand in some of your work so that you can be marked as present and participating. Okay, I will see you again in a couple days.